Hello dear student, I am Mrs. Pratibha Gopal Choudhary from Srimati C.V. Adarsh Vidya Mandir, High School and Junior College, Gandhibagh, Nagpur. Once again, welcome to the magical world of mathematics. Today I brought one new theorem for you in our journey of understanding theorem. This theorem is from the topic circle. It is chapter 3 in standard 10th. But as you know, before proving any of the theorem, we should know the basic things which we are going to use in that theorem. So some definitions are important to prove this theorem that I will take. And before that, so in your book, some circles are given there. So what is a circle? First of all, I know this is very basic thing you have learnt in your middle school too, but then also I want to revise it for you. What is a circle? It is a locus of a point which are at a fixed distance from a fixed point. The fixed distance is called a radius and the fixed point is called as the center of the circle. Now, which circles are called as congruent circle? The two circles or many circles which are having the same radius are called as congruent circles. Second thing is given there, concentric circles. Concentric circles, okay, some student gets confused here, but it's very cute and easy definition. You just see, I'll give one example to you. If you'll throw a stone in silent water, what happens there? A progression of circles formed. Have you done this thing anytime? This very cute thing to do. So if we'll throw a stone in a silent water, we'll see the circles goes around that particular stone. So they are having the same center where we have thrown the stone. So all that circles, infinite number of circles, they are having the same center. And the circles which have the same center are called as concentric circles. Okay. Now intersecting circles. Intersecting circles are those circles which are having 2 points in common. They intersect each other and in two distinct points, and that circles are called as intersecting circles. There are so many basic terms related to circle like radius, diameter, chord. You are all familiar with this. Chord is a segment joining any 2 points on the circle. Diameter is the longest chord which passes through the center. Radius is the segment joining the center and any point on the circle. And what is the relation between diameter and radius? Diameter is twice the radius, and what radius? It is half of the diameter. Okay, so these are very basic things. Now some definitions we need to prove this theorem that are here. The first one is tangent. What is a tangent to a circle? A line which touches the circle at one and only one point is called as tangent to the circle. And see this, line L is tangent and point A is the point of contact. The line tangent touches the circle at one and only one point, and that point is called as point of contact. Okay. Now next is the secant. What is secant? Again in the plane of a circle, a line is passing through the circle or a line is intersecting the circle in two distinct points, then that line is called as secant of the circle. Okay. Now next thing is not related to circle actually, but you have learned some axioms and postulate in 9th standard. It depends on that only. What are the axioms and postulate? Now this term is there. So axioms and postulates are the geometrical statement which we assume to be true. We don't need to prove it. उनको prove करने की ज़रूरत नहीं है. Okay, so this one of the axiom is there. We can draw one and only one perpendicular to a line from a point outside it. That means a line, if a line is given to you and a point outside that line is given, from this point to this line we can draw only one perpendicular. We can draw one and only one perpendicular. That also we will use here. Okay. Okay, now come to the theorem. A tangent at any point of a circle is perpendicular to the radius at the point of contact. This is called as tangent theorem. Okay, radius, in short, radius is perpendicular to the tangent at the point of contact. This we need to prove here. See, while proving anything, we are having two methods. One is direct method and another is indirect method. We usually use direct method. In direct method, what we do, we see the given things and then we use the concepts, basic concepts, properties, theorems related to that particular given, and we'll try to reach to the result. And definitely we reach to the result there. But here in indirect proof, here we are using indirect proof. Okay, so this is somewhat different from direct method of proving the theorem. Now here, whatever is given, we will use that given in the last. First we concentrate what we need to prove, otherwise every time we have to concentrate on the given thing. So we have to concentrate on what we have to prove. Here in this diagram, line L is tangent, segment OA is radius, point A is point of contact, and we need to prove line L is perpendicular to radius OA. So we will assume an exact contradictory statement for this. Assume that line L is not perpendicular to segment OA. We are proving line L is perpendicular to segment OA. We will assume that line L is not perpendicular to segment OA, and then we will proceed further. Okay, so just see, suppose now we know that we can draw only one perpendicular. So if OA is not perpendicular, there must be some other segment which is perpendicular to that line L. So we will take OB as a segment which is perpendicular to line L. Okay, now after taking OB perpendicular to line L, we will take 2 points such that A dash B dash C, that means point B lies between A and C, and BA is equal to BC. B is equidistant from A and C are equidistant from point B. After this construction, we'll just join OC and OA. So we got two triangles there, which are that OBC and OAC. These two triangles are there. We will prove that two triangles are congruent. As usual, in the last video we have seen the test to prove that similar triangle. Here we are using the test to prove the congruent triangle. So now in triangle OBC and OBA, it is given to, we have done some construction, segment BC is congruent to segment BA. A reason for that is construction. We have just now constructed that. You can see the second figure for that. And angle OBC is equal to angle OBA. Both of them, they are congruent to each other. Why they are congruent? Because each of them is a right angle. Okay. Now next is segment OB, which is common between these two triangles. So we will take segment OB is congruent to segment OB, and we will write the reason common side. By the group of these three elements which we have taken, we can say this triangle OBC is congruent to triangle OBA by SAS test of congruency. Corresponding elements of the both triangles are congruent to each other. In the same way, OC is congruent to OA, corresponding sides of congruent triangle. Okay. Now we know that we have taken what is this OA, it is radius. So OA is radius. Okay. If OA is radius, OC will also become radius because they are equal to each other. Now O is the center, A is on the circle. Okay, similarly we can say here again O is the center cannot change. So what about point C? It must lie on the circle then. If OC is radius, then point C must lie on the circle. But if point C lie on the circle, then what happens? It means that line L intersect the circle in two distinct points A and C. Line L intersect the circle in two distinct points A and C. But what is line L? It is given that line L is tangent to the circle. And what is the definition of circle? What is the definition of tangent? A tangent touches the circle at one and only one point. Here we are getting 2 points which are common to the tangent and to the circle. That means we reach to a contradiction. And given thing is line L is tangent. That means whatever we have assumed that line L is not perpendicular to radius OA is wrong. Our assumption is wrong, and therefore we can say line L is perpendicular to radius OA. And like this, we using indirect method, we reach to the result. Okay, dear student, Actually, while proving, you should not panic for anything. Just remember the concepts, properties, and very basic geometrical statements, axioms, postulate, etc. and try to prove the given result. And it's very easy. And one more thing, diagrams are again compulsory, that I am repeating again because it is a compulsory part of the theorem. Instead of panicking about theorem, just stay focused, pay your complete attention to the given statement and what we have to prove. I am sure with this journey of understanding theorem, you will be more accurate and confident in the future. Thank you so much, dear student. Stay focused, stay safe, stay home. Bye.